open this up in a window. Oh no, not the window. Oh man, in the Explorer. Okay, it is already opened. Wait, what? Where is this thing? No, this is not right. So open it up and then go to the server. Now we need to get access to the model H5 thing, to the model that we trained. So we can come over here. It is trained under Web Google Translate. Oh, and that's in a totally different directory. I'm just finding my stuff, but locate this, just copy and then paste it here. And then now we get access to the H5. There's gonna be a few things that the code doesn't seem to be intuitive, but it's just a lot of getting around with things. So really logically, you see that we have a keywords.load model function, and you can really just be able to do NLP model or translation model equals to load model.h5. But there is going to be a few problems when you do that. I'm not going to show you guys the actual what happens, but there are a few things that you have to do to bypass the weird stuff that happens when you load the model in the Flask endpoint, in the Flask app. Translator model, and then we gotta do global graph, and then do graph equals tf.get default. Again, I don't even understand what these code mean. I mean, like, their names kind of make some sense, but like, what does it really mean? That it is like a default graph. Or I mean, what does it really mean to clear session? Because clear session is the one that doesn't make that much sense. Now, if we go back to thinking about how this was trained, I mean, the training process is really the same thing as the testing process, at least how it's ran through the neural network, right? So in the training process, we had to convert these, remember the keywords tokenizer library? We had to fit on text these original English lines onto, and make them tokenized, which means converting them to integers, whatever. And then at that point you can run it through the neural network. But we need to know how to tokenize these, and with that, we need to get the tokenizers, which we don't right now. Good morning, guys. How is it going? I'm back at it again and bringing you guys positive energy. Alright. That was really cringy, wasn't it? It's my way. We have the model right now, and it seems like we can just do model dot translation equals to model dot predict German input, and then return that in the JSON-fied response. But that's not it, because we forgot two steps. If we just do that, we have to tokenize the input to the neural network, and then we run predict. But then also when the output comes out, we also got to untokenize the tokenized output. So let's do that. First of all, before we even get into the tokenized version, to tokenize it, we have to put it into an array, which is I don't know how to name this. Ready for tokenizes. np.array German input. And then, well, we don't have the tokenize. We have the tokenizer, but where is the function that tokenizes? We can get it from here. It should just be an encode sequence that does this, if I'm not trolling. not encode output. Encode sequence definitely does this. And encode sequence, does it need any other helper methods? First of all, let me create a new file called utils.py where I can import encode sequences. What else do we need? We don't need max length because we can just manually input the max length, and the max length is used for padding the input because we want to pad it to the longest word possible because it is a fixed sized input. And if it's like a 6-letter word but there is the max in the dataset is 10, then we'll just put like 4 zeros or something similar to the end. Create tokenizer. Well, we have the tokenizer already, but there should be something else. Where is the predict? And then train the. Oh, we never tested our dataset. Oh, we never tested our dataset. Okay. Well, we can come here. I'll come back to the tutorial. Go to evaluate neural translation model, and then copy and paste. Well, we gotta load all the packages probably, and then well, we have encode sequences. We do need word for ID so that we map the integers to the word. Yeah, we definitely need predict sequence. That should be it. And sorry guys, if you were more on the side of trying to like do, if you were more interested in doing machine learning, this tutorial, it was definitely not that machine learning. It turns out that I just copy and paste most of the things, but you know, it just mainly served to the purpose of quickly integrating things in the web, right? Because it's just really some special syntaxes that you have to use, and it's like a one-time learning deal. And you know, after you do this one, for every single one of your ML applications, you can just use this template. Oh, but there's a few things that you have to correct. For example, you don't want to use cores at all. And to bypass that, let's try bypassing this later, but not right now. I mean, to be able to not use the open up cores command. Anyways, this should be it. I don't know when I imported this, but okay. So ready for tokenize, and let's do tokenized neural network input is encode sequences, and we definitely need the tokenizer to encode, so it's German to English. And we definitely need the max length, which is 10. I memorized. Also, what do we need? Oh, we need the actual input. And let me see if that is right. Tokenizer length lines. Correct. And now we can run it through the neural network, and then this method incorporates both running it through the neural network and also translating the tokenized output to a normal German word. So to the normal English version. So translation equals to predict sequence. We need to put in the model. We need to put in the tokenizer. And we need to put in the source, of course. Let me see if that is correct. That is correct. So at this point, it should be it. I don't see an error with this, which means maybe we're good. There's something we have to do. I forgot how to write this. Is it like wrap dot is command? I mean, is default. Oh. This is just a TensorFlow thing. Like, to be honest, I don't know. I never use TensorFlow, I always use Keras. But I don't know why in this one, you know, it has so much to mess with the TensorFlow side. I mean, Keras is indeed, you know, part of TensorFlow, but on top of TensorFlow, but I still use so we can run it. Let's exit out everything just to be sure, and then do Flask run. Oh, by the way, if you're not using Windows, I think it's not Flask run. It's something like, it's a little bit different. Like, you gotta do export Flask app equals to first of all, versus, you know, on Windows you do set Flask app equals to, and then maybe it's also Flask run, but I'm not sure. It says that we don't have this package, so let's just remove it. Work. Okay. So I have a German word right here. This is supposed to say, "Hallo, mein friend," which translates to, "Hello, my friend." Translation is not defined. Probably typed something wrong. Man, I used to be the spelling bee champion of my house, and now, you know, got a little bit worse. Oh, I'm not printing anything here, so perhaps it shows up in here. And it prints no for some reason. So what I did wrong was didn't put in a German. I put in German input here instead of ready for tokenize, and that was why I was printing no all the time. Anyways, so I translated "hello, mein Freund," and it prints out "where's dog." So I'm both excited and concerned about this output, because that means when I'm trying to tell my translator app, you know, I'm trying to tell our German fellow, "Hello, my friend," I'm gonna say, "What's up, dog?" or "Where's dog?" which is not, you know, the most polite conversation initiator. However, the exciting part is that the German is indeed translated to English, even though it's not the most desired English. So with that being said, let's try a few more examples. First of all, I don't know any German, so I have to actually use Google Translate itself, which is the application I'm trying to emulate, and then insert the text here. First, water, Wasser, and hopefully this is really fly. Highly likely because my buddy haven't seen enough words, my motto, so it says doesn't recognize it. What is something that the dictionary definitely saw? Oh, I can just go to the dictionary. And then wasn't there yeah, so this is the English this is from the dictionary itself. And so if I input anything from here, it better work. Grugat. Supposed to translate a hi, that's kind of weird. That results in hi. Oh, let's try one more. Ich rannte. I ran. Okay, I even got the past tense right. Ich schwamme. I swim. Alright, so it remembers, but if I go longer, like, yeah, if I go a longer sentence, I doubt that it's going to function that well. Well, anyways, that is it, really. But I guess in the next video, And now we're going to run it through the neural network. Now the only difference between this and Google Translate is, first of all, Google Translate is owned by Google, and then second of all, this neural network is extremely poor. It has only seen 10,000 English to German word pairs, which is, if we contextualize that, that is like what? I would say that's like a mini chapter in a English novel. So how much examples is that? That is not enough words for the dictionary for the model to know what is what. And second of all, I believe in Google Translate they definitely have some programming besides just machine learning, which means it is going to correct itself of the most basic errors. It might have like a grammar detector, like when the English word is printed out. If the English output itself does not make sense in grammatically, it's going to correct itself. So it has an extra layer of translation that is done by algorithmically programming it, instead of just throwing it blindly into a machine learning neural network. So I will see you guys in the next video to update the UI a little bit better. Yeah.